Questions on 274?
13.
Yes, 13.
Population mean and standard deviation are given. Find the required probability and determine whether the given sample mean would be considered unusual. If convenient, use technology. How about your calculator, so you can help me until I go grab mine? 13, it says N is
He was so good.
64. And probability sample mean being less than 24.3. U is 24. And sigma is 1.25. We want the probability that our X is less than 24.3. It's going to be important to make sure that you can write stuff this way with what we do today. Your X is less than 24.3. It's not going to be 24.3, but the stuff that we're going to do today is going to be something like this. I think on this we can just use our calculators, right? And again, you don't have to change everything into standard scores or z-scores. You can leave it at that if we use our calculator. What is it on our calculator? Is it, which button or which thing do we use? I have my calculator.
Bars, isn't it?
Which one is it? So you do second, bars, then where does it go to?
Is it normal CDF?
Is it the normal CDF? Is that the one we were using?
CES if you put one of the one in, or if you're doing like a whole group.
So this time we want less than 24.3, so do we want CDF or PDF? CDF.
Okay. That's what I was confused.
And what things do we put in?
24, right? So
Do we put in a low limit, a high limit,
and then the 1 point, and then 24.
and the
No.
mean and standard deviation? Or actually, this isn't standard deviation, this is standard error, correct?
Yeah. You could put in like negative 100 or whatever.
So put in negative 100. 24.3 is what we're going up to. 24 is our mean. 1.25. Now some of this is going to be the same for the stuff we do today. It's going to be a little different to find the lower limit and the upper limit. Punch that in, what's it come out to be? Ah, no, we messed up. Remember for this, sorry, I've been off for the weekend, forgot all about it. We have our mean, this is our standard deviation. We got to find
Oh,
the mean of the samples. What is the mean of the samples?
It's the same.
It's the same thing, but we also have to find the standard error for the sample means.
If I did it right, I think it's
And that means that we have to take this and we do what?
Square root, right?
We do 1.25 divided by the square root of n, which is 64. So we need that number. My fault.
I think it's 0.16. I don't know.
0.16 for this.
That's what I got.
So make sure you're doing that, and make sure, because we got a test coming up, probably next week.
So,
Punch that in.
So you take the standard deviation and then divide it by the square root.
Divide by the square root of n. So this is standard deviation divided by square root of n.
You get 0.51.
And for that one, for the normal CDF, it's like negative 100, negative 1,000.
Right, it could be whatever there.
Wait.
Where you confused at?
Then if it's like greater, if it's opposite, the arrow's going the other way, you would put 24.3 first and then like 100 or
Cause I
whatever.
put that in and I did not hit.
You didn't get 0.51?
Let me try it
Normal
again.
CDF? I don't have my calculator, so.
Because I just hit second and enter and then put 0.60 in there.
Yeah, that's not what I got either.
So did I?
Yes. Trash.
Second.
We got that, we got that, we got 24, we got that.
Normal CDF. Negative 100, comma, 20, and then 4, 3, comma, 24, or, yeah, I got the same thing.
What'd you get?
0.97.
That's what I got.
You do it.
I got it twice, so.
That's what I got.
You typed it in there.
Who, baby?
Let's see.
I still got.
Oh, what?
You got your 24.3 and your 24
Oh, switch.
switch.
Oh, that's what it is.
Some of it.
So
There you
then,
go.
Isaac,
So it should be about 0.97, which is a probability that's about 97%. So what we're saying, again, what we're saying is, for this problem, just reading through this, for a sample 64, sample mean, if we pick 64 out of this sample, and we do it over and over and over and over again, we would expect our sample mean to be less than 24.3 about 97% of the time. So if we picked the sample and we came up with a mean that was 26, that would be considered unusual, because 97% of the time we expect it's going to be lower than 24.3. So for this one, we can say that this is not unusual. It's not unusual because it's not less than like 5%. Again, don't mess up. I messed up at the beginning. Make sure when we're doing stuff like this, the very first thing you gotta do, you gotta find the mean of the samples and the standard error of the samples. I forgot to do that when I did it first time. That's why we got that other crazy number. And that would have been all right if we knew that this was all normally distributed and we were picking certain samples and everything. We would have just went that route, but when we're doing sample means, then it's gotta be that way. We have to find those. Other questions?
oh my gosh, who it is?
Other questions?
Who is it, Cody?
Yeah.
Yeah.
21?
41.
41.
Yeah. How you been, Cody?
41. Let's skip 41. I won't put anything like that on any test. They're just, all 41, it's another one of those problems where they give you a different formula, those different formulas up there,
That's why I did.
and I just don't feel like reading those whole paragraphs, so
I
Good
got
job.
you.
I'm not gonna throw anything like that on any test or anything. Other questions? On page 274, Cody. 17. Says the amounts of times employees at a large corporation work each day are normally distributed with a mean of 7.6. and a standard deviation of 0.35. Random samples of size 12 are drawn from the population and the mean of each sample is determined. So our N is 12. They want us to find the mean of the samples. What do we know about the mean of the population and the mean of the
It's the
samples?
same.
So if that's 7.6, then this has to be 7.6. That's one of our answers. They want us to find the standard error.
But you
You gotta take the standard deviation and divide it by what?
Square root of,
So somebody help me out with that, 3.5 divided by the square root of 12.
1.01.
So that's two of the things they wanted. Then they wanted you to draw this. Now, I'm gonna do this. I'm gonna try to do it correctly this time. If we have just our normal, they told us that this one was normally distributed. So the 7.6 goes right in the middle. Help me out with your calculators. If it's 7.6 and the standard deviation is 0.35, what's the first one here? I think I can do that one.
I'll make it.
7.95, right?
Yeah.
Now add another 0.35 to that, tell me what the next one is.
8.3.
Then add another 3.5 to that.
3.65.
Now go back to here, 7.6, and subtract 0.35.
7.
7.25.
Subtract another 0.35,
6.9.
and then subtract another 0.35. 6.55. So if we're just doing, if we're just doing the normal curve for this information, that's what it'd look like. Now, again, mine's not spread out enough. My curve, let's make it, try to make it look a little better. Let's get rid of the curve. Because the curve should actually, that's not a whole lot better, but the curve should actually look something like that. If we're taking all these samples, if we're just taking samples of 12, and we're finding the mean of each one, so the sample means, and we're gonna make a curve out of it, it's gonna look something like this. I'm gonna put 7.6 right here in the middle again, and then 7.95, and then 7.25 on this side, and it's gonna keep going. I'm not gonna draw all the rest of those out, but it's gonna be something like that. If we put that, go back to this, I messed this up. Not supposed to be 3.5, it's supposed to be 0.35.
That's what I was thinking. I was like, hang on.
Holler at me.
That's what I did though.
That's twice today. I'll try that again because that doesn't seem right. What should be true about the standard error in relationship to the standard deviation?
Shouldn't the standard error be this?
Yeah, it should be 0.10.
Yeah. You just had it backwards.
All right, so I just had the decimal in the wrong spot. So when we do that, 0.1, that means here we're going to go out to 0.77, 0.78, and 0.79. And on this side, it's all going to be right here. So our curve's actually going to look something like this now. And it's not going to go below the line ever. But instead of being this big curve,
Now it's that small.
now it
Skinny.
should be just as tall as the other one, but it's going to be right underneath there. And again, what we're saying is, if we pick 12 people, we expect that the mean of those 12 people is gonna fall in there a certain percentage of the time, all the time. That's where our mean. So if we pick 12 people and we come up with a mean that's 6.9, then that's very unusual. These are our answers that they wanted, and then they wanted you to draw this graph. Be able to draw those graphs. Again, my graphs aren't drawn very well. I don't expect yours to be spectacular or anything, but you should be able to find 3 spots above, 3 spots below, and put in your how much it goes out each time. Other questions? Yes, no, maybe? Brady can handle all that. It's all easy stuff. A little tougher today, not really tougher, just different, and you've got to be able to get lucky. I'm going to skip the quiz. The basic idea for today, I talked about this at the start of this chapter. If we have something that sort of looks like it's normally distributed, so it's that normal curve. Mine, that's horrible. Yep, more like that. If we have something that's that normal curve, what we're going to do today is we're going to try to take this and approximate it to be a binomial. When we did stuff back in chapter 4 that was a binomial, that made everything a lot easier. And that's what this is supposed to do. Now we're probably, since we use our calculators 90% of the time, we're probably not going to change it to a binomial most of the time. We're probably just going to say the heck with that. Let's just use our calculator to find it. But what it does when we approximate it, and I talked about this at the start of the chapter, it takes this little piece and like sticks it right there to fill that in. So we're looking for that part of the curve. The bad thing with the binomials is that if we had something like, let's say our mean was 10, this might be 8. Well, we're looking for the area from here all the way over to there. Well, that doesn't just include 8, so we can't just put in 8. Our midpoint here was 6, so on, so on. We need to figure out what this low limit is and what this high limit is. And that's what we're going to do with some of the stuff today. And it's not as hard as I just made out to be. If we made that 9 or that 10 and this 9 and this 8, for our 9 there, how far up would this go? If we were halfway in between 9 and 10?
9.5.
9.5. How far down would it go? 8.5. That's going to be our low limit. That's going to be our high limit, and you're just going to have to figure out those limits so that we can punch them into our calculator. So normal approximations to a binomial distribution. So we're taking normal approximations. We're just sort of estimating, approximating these to a binomial. With a binomial, remember with a binomial, certain things have to be there. You have to have independent trials, so they have to be independent of each other, all the trials. Always 2 possible outcomes, a success, a failure. P is your probability of that happening. And the probability has to be the same for each trial. So you can't have one trial that's got a probability of 40%, then the next trial have a probability of 60%. Probability's gotta be the same for every one of the trials. That's all stuff that we talked about back in chapter 4 when we were doing binomials. It's what makes something a binomial setup. Main thing there, 2 possible outcomes: success, failure. Cody, you been getting all my emails? You gonna get yourself caught up? Let me know what you need, all right? Again, for most of this, I'm going to teach you this, and you're probably not going to use it because you're probably just going to say, let's just use the normal CDF or PDF on most of it, all right? Normal approximation to a binomial. Let me get all this up here, then I'll tell you what's probably important here to write. Normal distribution is used to approximate binomial distribution when it would be impractical to use the binomial distribution to find the probability. Remember back in chapter 4 when we had the binomials and we learned to use the CDF instead of saying, all right, we want from 100 down, and then you'd have to do the thing 100 times. And Riley would look at me and go, yeah, I ain't doing that. So we used, instead of binomial PDF, we used binomial CDF to find each thing, to find the total all the way down. That's what this is. Well, the calculators do all that for us now, so we really don't have to worry about it. So this was set up before the calculators had that CDF on it. So normal approximation to a binomial distribution, this part you do need to know. This has to be true. N times P has to be greater than or equal to 5, and N times Q has to be greater than or equal to 5. This decides whether we can use this setup or not. If N times P isn't greater than or equal to 5, or N times Q isn't greater than or equal to 5, then we can't use it. On this, and I'm going to tell you this, and you just have to remember it to make everything easier on you. You only have to do one of these. Don't do both of them. Only do one. So figure out whether P or Q. Use P or Q, whichever is the smaller. So when they tell you the probability, use the one that's the smaller of the two. Either P or Q. And that's the only one you really have to check. Because if you check the smaller one, then the bigger one's going to be larger than 5, and we really don't have to do the extra work. These two things are important. We did this in chapter 4. To find the mean of a binomial, this is all stuff for a binomial. To find the mean of the binomial, it's just N times P. And to find the standard deviation, it's the square root of N times P times Q. We did that in chapter 4. Those are the only things on that, all of this whole page that's very important. So if they give you something like, in the problem, they say 70% of whatever, and they say, you pick 35 people. All you really have to do to decide whether you can actually do this approximation or not is look at 70%, that's our P, so that's 0.70, and you're going to take it times N, so 0.70 times 35. But we really don't want to do that because if P is 0.70, what's Q? 0.30. Just do the smaller one. So we take 0.30 times 35. Because if one of them is going to be smaller than 5, it's going to be the one that's the smaller percentage. So we just check that one, and if that one checks out to be bigger than 5, then that means this one over here is going to be bigger than 5. So we only have to check one of them, really. Remember with a binomial distribution, we talked about this, it looks something like this. The more n's you get, the higher your n is, the closer and closer it gets to being, looking more like a normal curve. And I'm not sure why my normal curves keep going below the line today, but they're not supposed to. So the more n's you get, the better off you are, the closer you get to that normal curve. Decide whether you can use normal distribution to approximate X for the number of people. 62% of adults in the U.S. have an HD TV. You can tell this is old because if you don't have an HD TV now, what happens?
You can't watch much.
I didn't think they don't make HD TV.
You can't watch anything.
Yeah. Unless you got one of
A
the
few
old-
years ago, you had, my wife used to have, because our TVs were all old and outdated and we weren't buying new ones, so she had an antenna, those antennas that Walmart sold, sitting on every TV so that we could watch some of the regular stations and stuff. Now those don't even work anymore. You just can't watch anything.
My grandparents had a TV from the 70s in their kitchen still. One of those old box TVs. My grandpa was sitting there watching it.
My wife got upset with me for many, many years because when we go out to buy a TV for our living room, it always had to be a console TV. And after about 1990,
They would make those.
you couldn't even find them anywhere. So I said, we'll find one somewhere. We just won't have one for a while. We'll find it somewhere. And we'd end up finding one. And the guys would look at us all funny when we want this one. What? But then that didn't work anymore once they changed everything had to be HD. So what's our P this time?
62.
0.62. What's our N?
45.
Now, if P is 0.62, what's Q?
0.37.
Close.
38.
Oh.
Which one of those is smaller, P or Q?
Q.
So all we do to check, we just want to make sure that N times Q is greater than or equal to 5. So somebody help me out, what's 45 times 0.38?
17.1.
Is that greater than or equal to 5?
Yes.
Yes.
So do we really have to do the P part?
No.
Because P times 45 is going to most definitely be larger than that, so this will work. Then it says find the mean and standard deviation. The mean, well, we do have to do P times N now, because the mean is P times N. So what's 0.62 times 45?
It's 27.9.
So that's our mean. Our standard deviation is N times P times Q, the square root of that. So if you got this number on your calculator, just take that times Q, which is 0.38, and then take the square root of that answer.
3.26.
Now, if we had to draw a graph for this, which they didn't ask us to do this, but if we had to draw a graph, that's terrible. 27.9 goes right in the middle. We go out 3 spaces this way, out 3 spaces that way. 3.26, that's going to put us about 31, so on. And we just add and subtract the 3.26 each way. So we did all that, 27.1, 17 point, or 27.9, 17.1. Mean is 27.9, we just found that. Can quit working again. And standard deviation 3.26. 12% of adults in the U.S. who do not have an HD TV in their home are planning to purchase one in the next 2 years. You randomly select 30 adults in the U.S. who do not have an HD TV and ask them if they're planning to purchase one in the next 2 years. What's our P this time? So 0.12. What's our Q then?
0.88.
And our N this time is what?
30.
So what are we going to see if we can use this binomial stuff? What are we going to use?
Say 30 times 8.88.
Times it by this one?
No.
0.12.
Times it by the small
You
one.
always times it by the small.
Times it by the small one, because the bigger one we know is going to be larger than 5. So what's 0.12 times 30?
3.6.
Is that bigger than 5?
No, so it doesn't work.
So we cannot use it. Can't use the binomial setup. We'd have to find some other setup for this one.
So we just don't.
Yep. Since it's that, we can't find the mean and standard deviation because it's not a binomial. It won't work as a binomial. Binomial distribution is discrete. Remember, discrete means it's just dealing with that one certain number. This is 6, then that bar right there stands for 6. Doesn't stand for 6.1, 6.2, 6.3, all that stuff. It's just discrete. Everything we've been doing this chapter has been continuous. So it goes 6, 6.1, 6. It contains all of it. To calculate the exact binomial probabilities, if we use that binomial formula, you'd add them all up. So if we went like this, 6, then 5, then 4, we'd add those 3 bars. We did that last chapter. Geometrically, this corresponds to adding the areas of the bars. So what all they're saying here with all this stuff is we're trying to find, if we're dealing with that right there, we're trying to find the area under the curve. Like right there, all of that stuff. So we're approximating it to that area. When you use what we're going to learn here is this correction thing. I wouldn't write all this down because I'm going to give it to you easier. Continuity correction. Write this down. That word or that phrase. All we're going to do to do this correction, we're going to make the curve fit with our binomials. And to do that, you're either going to subtract 0.5 on the low end or add 0.5 on the high end. This isn't near as hard as it sounds. I'll show you here in a minute. Now, what is hard about it is you got to stop and think as you do it. And that's where drawing the graph and looking at it and stuff might be helpful. So for the continuity correction, you're just going to, for the low end, you subtract off, and we did that back at the very beginning of the lesson. Subtract 0.5 on the low end, so you subtract off a half on the low end, maybe add a half on the high end, depending on what you're trying to get to. Now I say that, you very well may subtract off 0.5 on the high end, depending on what probability you're trying to find. That's what makes this a little more difficult, because you got to actually stop and really think about, okay, what am I doing here? What am I looking at? So if we were doing something like this one, the probability of getting between 270 and 310. So we're on our graph, and I'm not going to draw the graph. And it says inclusive here. I'm not going to draw the graph, but we want to go 270 all the way up to 310, and we want to include 270 and include 310. So to be between those two, from 270 up to 310, on this end, if we're on our graph, if our bar looks like this, and that's 270, we can't just stop at 270, because that's going to stop us right there. So we want to go clear down to here. Well, all we're going to do to get down to there is go down that half. So we want to subtract off 0.5. So we want to go from 269.5 all the way through, what are we going to do on this end? So we're going from here all the way up to there, so that we include everything on both ends. We want everything that's in the middle there. Now the bad thing with this is, and just like with the alligator mouse, and everybody always loves all the alligator mouse stuff, is that ever confusing when they got the less than or equal to and greater than or equal to? You never get confused by that, so this stuff should be easy.
When there's 5 of them, they're a problem.
All right. When we're looking at that, you got to know, hey, what am I doing here? Am I going all the way down and including this? Am I not including it? And that's what you got to think of here. You got to really think it through. Probability of getting at least 158. So if we want the probability of getting at least, probability of at least 158. If I'm on my graph, wherever 158's at, so on, so on. If I want at least 158, am I including 158?
Yes.
Yeah.
So do I want to stop right here?
No.
Do I want to start right here and go up?
You want to start at 158 and go up.
Do we want to start right there and go up?
Would you want to start below 158?
Because
Oh, you got to include
You gotta
158.
we got to include that, right? So we want to start right here. Well, what's that number going to be? 150. 157.5. So drawing the picture might help you out just to get an idea there. So we're going from 157.5 and up. So if we were doing the probability that X is greater than 157.5. That's it. Probability of getting fewer than 63.
So you start at 62.
So if I'm looking at 63 right here, 62 would be over here somewhere, right? Again, I don't know what 64 would be over here. It doesn't matter what the bars look like. We want fewer than 63. So am I going to start right here?
No.
How about here?
No.
Like
Right
right there.
before.
Right there's where we're going to start, and we want from there down.
62.5.
So when we write our probability, it's going to be probability that X is less than 62.5. And what they're doing here is they're saying, okay, what do we want to include? We want to include 60, 61, 62, and everything down that direction. So as you do this, things that you want to do, verify that it can be a binomial, determine if you can use the normal distribution stuff and the binomial together. And that's just by doing n times p or n times q. Find the mean, standard deviation. It's been a while since we've done one of these lists. If you want to write some of this down, these are the things that I would write down out here. Mu is n times p. Sigma, standard deviation, is just the square root of n times p times q. Remember on number 2 here, only you do the smaller one. Smaller of p or q. Don't do both. You don't have to do both. It's a waste of time.
Can we use the restroom real quick?
Do the continuity correction. Add 0.5 or subtract 0.5 on the endpoints, depending on how you're doing it. Make sure you're looking at the picture. This. That's how you change something to a z-score. We're probably not going to change it to a z-score. Then find the probability. This says use a table. We're probably not going to use a table. We're probably going to use our calculators. On your calculators, I'll give you a second to copy this down. Let me move that so you can see it. Don't just write down the lower stuff, write down the top stuff also. You've got to make sure that you find the mean and standard deviation. Don't screw up like I did a few minutes ago.
Can I go to the bathroom when Isaac gets back?
Yeah. So you've got to make sure you find each one of those first using the formulas that you just wrote down. On the other thing, make sure you do the continuity correction for each one. That's the way the problem's set up.
Like go in with it. That hurts. Oh, you're saying belly. I don't know, he told me. He said, yeah, he said that, yeah. Put a strike. Can you give me your strike? They are?
Yeah. You can't see it. In the library?
In the library, they are. I thought you were talking about Chio.
Oh, no.
So we're changing all this into normal. So doing the normal CDF. So your second bar is normal, low limit, upper limit. On your upper limit and low limit, you got to make sure that you do that correction if need be for this certain problem. Mean, remember, if we're setting it up using the binomial stuff, then the mean is n times p. Standard deviation is the square root of n times p times q. Some of the times they may tell you the mean and standard deviation. You may not have to do that, especially if we're just using the normal and we're not trying to change it into the binomial setup. Also remember that this works whether they ask you to find the area under the curve or probability, they're both the same thing. So don't let that confuse you. The other thing, when you start to do this, please, especially on the test, when we have a test over this stuff next week, draw yourself a little curve, put your mean in the middle, standard deviations going out to each side, sort of draw it maybe a little better than mine. Decide where we're going from, and when you get your answer, ask yourself if it makes sense, what that percentage is. Make sure that everything makes sense every time. If you're using a calculator and you can't use the normal or just using the binomial, then you don't need this stuff over here. Remember, for binomial, this is what we did for binomial back in chapter 4. So if you know it's a binomial and you're just using the binomial stuff, also on this, don't forget that binomial PDF, that's for one certain thing, like 85. If you want the CDF, then on our curve, the CDF is from whatever that number is downwards all the time. And I think with the binomial, did we figure out that you could use CDF and you could use the high limit and the low limit, or not?
I think that's what we did last time.
I know that's on the normal stuff, but I can't remember on the binomial if that was the case or not. We'll figure it out as we go, I guess. See if we can do this, because I was trying to do this problem and I don't think it was working out right on my calculator, so we'll see if we can figure it out. 62% of adults in the U.S. have an HD TV in their home. You randomly select 45. So our P, 0.62. Our N is 45. What's our Q then? Close.
Oh, 0.38.
I know, you keep going one lower.
You said the same number last time.
I know.
What is the probability of fewer than 20? So we want the probability less than 20. If our probability is less than 20, or when we pick this, that we get less than 20, that's what we want.
So you start with 19 or you put that in.
So again, when we're looking at it, we can find our mean. First, let's find our mean. What's our mean? Well, first let's check, see if we can do the binomial stuff. Which one of these do we want to multiply by n?
0.38.
So what's 0.38 times 45?
17.1.
So we're all right, so that checks out. I forget to do that all the time because I just look at it and can sort of tell off the top of my head that, hey, this one's going to work, so you'll have to remind me. So our mean is 0.62 times 45, what is that?
27.9.
Our standard deviation, take that number times 0.38, and then take the square root of that.
0.26.
Now, we look at this problem and they said respond yes. So that's telling us we can use the binomial stuff because it's either yes or no. So that works, and it checked out that it worked up here. So we're looking at this. We got our mean is 27.9. That's going to be right here. I'm just going to round this off to 3, and it'll go like 30, 33, 36. I know that's not exact. Don't go by that. Going down by 3, that'd be about 24, or let's go 25, 22, 19. So it's going to be somewhere, our curve's going to look something like that. We want less than 20. So we want at 20 here, somewhere about in here. And we want everything down this way. Should that be a big area or a small area? Should be small. Now to do this, to change it, we want less than 20, so it's actually going to be probability X is, if we don't want to include 20, we want to just go down from 20. X is less than what? What are we going to do to that 20? 19.5. Now when we go to punch that into our calculator, we can just do, instead of doing binomial, we can do the normal. So we do normal, CDF, and for that we put in the low limit, the high limit, the mean, and the standard deviation. What's our low limit this time? Yeah, just some negative number, negative 1,000 maybe.
And then 19.5.
19.5 is our high limit.
The numbers at 27.9.
3.26. Punch that in. What's that tell us? Let's hope we get it right.
I got a 0.005.
So less than, it's about a half of a percent, right? So about a half of a percent chance that if we do this, we get 20 people exactly, or fewer than 20 people who say yes. Does that small percentage make sense for what we have here? Yeah, it makes sense that it should be a small percentage. Since it's that small, what do we know about this?
That is unusual.
Very unusual.
All right, this one happens to be very unusual. If you just put unusual, I'd be all right with that, but it's going to be unusual. See if we get pretty close to that. There, that looks right. Our mean, standard deviation. Our graph looked about right. They changed the graph into the z-scores, which we're not doing because we're using our calculator. And they got about 0.0049. Is that pretty close to ours?
Yeah, well, that's what I
It's
got.
almost
I just
like-
shortened it.
So that's what we should have gotten. Exactly 96. Do this one real quick. Same idea. P. If it's 62%, that's 0.62. What's Q then?
Wait.
0.48. That was like 3.8. You guys are-
3.7 actually.
No, it's not.
I know. I'm just kidding. Because
Randomly select 150, so our N is 150. This is one of them that we would not want to do out longhand, doing the binomial stuff. If we take Q times, if we take 0.38 times 150, is that going to be bigger than 5? Yeah, so this one checks out, it's going to work.
Yes.
We want exactly 96. So when we do our, well, first let's find our mu. What's mu this time? P times N is,
P times 10.
that's our mu,
Yeah.
93. Does everybody agree with that?
Yeah.
Sigma, take that answer that you got times 0.38. remember it's square root of P times N times Q, sorry, I'm writing it backwards from what we wrote it down in the notes, but it doesn't matter. What's that?
I got 25.9.
5.9 what?
Four.
If we were to draw our little graph for this, 93 goes right in the middle. We're going up about 6 each time, or down 6. That'd be 99, 105, 111. Down 6 would be 87, 81, 70, 75, something like that. We want exactly 93. So we're looking at this bar just right here in the middle.
We went 96.
Oh, we went 96, my fault. So ignore that. 96 would be somewhere like in here, right? So we want that bar. Now, at 96, are we just going to put in 96?
Yeah.
No. What's our, if we're at 96, what's our low limit going to be?
95.5.
95.5. All right, so we want the probability that X falls between 95.5 and 96.5. So when we punch it in our calculator, what's our low limit?
95.5.
What's our high limit?
96.5.
What's our mean? What's our standard deviation?
That was a 6.
5.94.
5.94.
Wait, do we have to put 5.94 since?
Yes.
Okay.
Yeah, just don't go by my picture when I'm just being lazy and don't feel like adding the decimals.
0.059.
Anybody else get that? So about what percentage falls at 96?
About 0.6 or
About
0.06.
0.06, so about 6%. Is that unusual?
No.
It's close, but
Not quite.
looks like we did all that right. We want just that. So when we did it, 95.5, 96.5, and the area we got, ooh, that's not what they, oh yeah, maybe it is. 0.0596.
Well, ours is 0.05906.
So since we use technology and they changed it to a Z-score, there's a little bit off there, but still pretty close. Again, low limit, upper limit, mean, standard deviation. If we're doing just the binomial stuff, then we go back to just putting in N, P, and X. That's the assignment. We got about 10 minutes or so to get your books out, and we'll start doing some of these together. Skip through them and stuff, try to, because I looked at it and some of them may get confused on. Once you get your books out, number 1, number 2, you can do on your own. That's just in the notes. We'll start and we'll do like one from that next section and so on and so on. So some of them will be easy also. So we'll start with number 3. Actually, I'll let you pick 3, 4, 5, or 6, which one you want to do.
Is it 3, 4, 5, or 6?
Yep.
5. Why? 5.
So 1, 2, 3, 4, you can do on your own. 5 says sample size N, probability of success P, probability of failure Q. Given the binomial experiment, decide whether you can use Normal distribution to approximate the random variable. So we're just deciding, can we use the normal distribution setup or can we not? Number 5, they tell us n is 18, p is 0.85. Sorry, I'm not writing all this down. That's p. Q is 0.15. What do we do to check to see if we can use it or not?
Add the small thing.
So just pick the smallest one, that'd be Q this time, so it's just 18 times 0.15. What's that give us?
2.7, so it doesn't work.
So can we use it?
No.
No, this is less than 5, so cannot use. Three, 4, and 6 are the exact same thing there. You're just deciding whether you can use it. Seven through 12, pick me one.
7.
Says a binomial experiment is given, so they're telling you it's binomial this time. Decide whether you can use normal distribution to approximate the binomial distribution. If you can, find the mean and standard deviation. If you cannot, explain why. Your explanation why would just be showing that, hey, it wasn't more than 5, whatever it is that we do.
Wait.
You want to?
287, right?
Yeah. Is that not what it says?
No, mine doesn't. Mine says survey of U.S. adults
Oh,
now.
I was reading directions.
Oh, okay.
Sometimes you do that before you start a problem.
Well, yeah, I was like,
Oh. Come on now, that's my younger students, not my senior students.
okay.
A survey of U.S. adults found that 85%, so what's our P? 0.85, what's our Q? Read every word or at least enough to understand a contract before buying or selling a home before signing. You randomly select 10 adults. So what's our N? And use normal distribution. A binomial experiment, decide whether, so that, again, we're just deciding whether we can use normal distribution or not. What are we going to take times each other this time?
2
So 0.15 times 10, what's that give us? So can we use it? And that's a good enough explanation why you can't use it. If you can use it, they want you to find the mean and standard deviation. Now we can't on this one. How would we have found the mean?
You take, is it
N times P. How would we find the standard deviation if we could have?
multiply that by Q and then take the square root of
This one we couldn't, so, but if we could have, then they want you to find those two things. Does everybody understand those? 13 through 16. Pick me one.
14.
Does that say 109?
Yeah.
So we're looking at this graph and 109's on here somewhere. That's our bar for 109. We want X, we're trying to find the probability that X is greater than or equal to 109. So where are we starting at? Are we starting here? Would we start right here and just go there over?
No.
Would we start right here and go there
Yeah.
over?
We start at 108.
Would we start here
Yeah.
and go over? So what's gonna correspond to that number right there?
108.5.
So when we find our probability, and this is us correcting this, we want the probability that x is greater than 108.5. Is that one of the things over there? I guess we could put equal to with it. Is that one of the things over there?
Oh, is it, we're matching it up?
Yeah.
Okay. Yeah, it is.
So which one is it?
D.
So D has to be the answer to 14. I'm not sure why they put the equal to sign with it. Because it doesn't, that doesn't affect anything really. How far, where did we go to, 21? Is that what it said?
23.
23, all right. Pick me one, 17 through 22.
19.
19. Same idea. This time they said probability of x is equal to
23.
33. We want to change that. I'm not going to draw the picture this time. We're going to have x between what? Well, I will draw the picture. We got 33 right here.
32 and a half.
32.5. 33.5. What do they want us to do on that? Binomial, or probability in words. Don't worry about writing in words. Binomial probability to a normal distribution. Just write this. They just wanted it written that way.
We do 22 also.
22. Let's see. So we start off at probability 55 less than x, which is less than 60. Is that right?
Yeah.
So when we're looking at this, we got 55, 55, 56, 57, 58, 59, 60. We got our bars here. We want x is greater than 55. So where are we going to start at?
We're going to start at 55 and a half.
We're going to start right here. And x is less than 60. So where are we going to start at?
59 and a half.
Then if we're doing this on our calculator, that's going to be our low limit. That's going to be our high limit. And we punch in all the other stuff, mean and stuff we can find. But that's the answer they wanted right there.
Oh, shoot.
23, 25, 28, so on. Which, pick me one of those. Try to do one of them real quick.
28.
Maybe not. We'll see. 28. We probably won't get it all done, but we'll get it set up. A survey of U.S. adults who attend at least one music concert a year found that 67% say concert tickets are too expensive. So what's our P?
Maybe 567.
So then what's Q? Don't let Lily answer.
23.
Point what?
33.
select 12 adults. So our N is 12. First thing we gotta check, see if this works. 0.33 times 12, what's that give you? Hey, we will be able to get this one done. No, not quite.
3.96.
So can you use the normal stuff?
Yes.
What did it come out to be, say it again? Point,
3.9.
is that bigger than 5?
No, 3.96.
Is that bigger than 5?
Yeah.
So we cannot use. But what we can do, so on this one, you can't use the normal distribution. So what you'd have to do is go back and use binomial CDF and PDF. So on your calculator, you'd have to use one of those two because we cannot switch it over to the normal stuff.